Okay, this is an overview of charging the Tesla Model 3 whenever you're traveling and you're not using the supercharger network. I'm here at the High Point Public Library in High Point, North Carolina, where they just happen to have free charging options here. They have a J1772 charging station with 2 chargers available. They also happen to have a box here, which is similar to outlets you'll find at an RV park or a campground, that has various options here to charge as well. Realize whenever you're in an EV, whether it's a Tesla or another EV, there are lots of places to plug in. Even out in the middle of nowhere, you can still plug into a 120 volt outlet. You can find various 240 volt options to charge, as well as public charging stations, some that are free, some that cost money to charge your vehicle. Of course, the nice thing about a Tesla is we have the Tesla supercharger network, which allows us to travel pretty much anywhere in the United States and be able to charge quickly. However, I've driven over 30,000 miles. This is a Tesla Model 3 Performance, and I got this back in October of 2018. And I almost exclusively use supercharging because I travel so much, over 30,000 miles from Pennsylvania to Colorado, down to Florida, and back and forth over a long distance. But when I get to my destination, I need to be able to charge my vehicle while I'm there. I may be far away from a supercharger, and really superchargers are meant for getting you from point A to point B if it's over a long distance. Now at home, I do charge with a Tesla wall connector, and that's hardwired into a 60 amp circuit where I can charge at the full, I believe it is 48 amps, 240 volts, and that's about the fastest you can charge outside of the supercharger network, but that can fill your tank pretty quickly. Now I'm going to go over some of the other options when you're out and about. So when you get your Tesla Model 3, you will get these adapters here. You'll get the Tesla mobile connector. You'll get 2 different kinds of adapters. This is a NEMA 1450. This connects to a 50 amp circuit, 240 volts. This is a standard plug you'll find in a lot of new modern installations at RV parks and in some homes. A lot of people install this kind of plug in their garage. Then you also have the NEMA 515, which is your standard outlet plug for 110, 120 volt connections here in North America. Notice there's 2 vertical slots here and a ground plug. Also comes with a J1772 adapter, also called a J adapter, that converts the J adapter plug to the Tesla proprietary plug. And you can see that the 2 ends here are both the Tesla plug, and it's the same plug design you'll find at the superchargers as well. So at this particular installation, this is a free charger. Looks like this charger is from a company that allows you to charge for it, but at the library here it's free. The screen's also not working right, but the charger is working. Unfortunately, at a lot of these stations, superchargers are pretty good. A lot of these EV stations you'll find, sometimes they don't work, they're broken. You'll find people that park in them, called icing, where an internal combustion engine car is parked in those areas. So they're hard to come by. A good app to look for these kind of stations is called PlugShare, and there are others. So just to convert this adapter, the J1772, use the adapter, and it turns it nicely into a Tesla adapter here. Unfortunately, the way they put these parking spots, I have to really pull on this cable, but it fits in nicely. Changes from blue to green. Blue is communicating, green is charging. Now we'll go inside the vehicle, and you can look on the main screen and see how the charging is coming along. So you'll see here, we're getting 238 volts. It's ramping up the charge to 25 amps. This particular charger provides 25 amps of power. you'll find that that amperage varies depending on the charge you're at. Some are less, some are more. You want the highest amperage possible because the number of kilowatts is really the amount of power you have to charge your battery. So this is going to provide 6 kilowatts of power, and you'll see later that a 120 volt plug typically gives you 1 to 2 kilowatts, and the NEMA 1450 will typically give you about 8 kilowatts using the Tesla mobile connector. If you have a Tesla wall connector at home, you can use higher amperage up to the maximum that the Tesla Model 3 supports, as well as the Tesla Model S and Model X. Some of the older Model S's and Model X's had higher amperage charging options available, which you can no longer get, and they can even charge faster. But that was kind of before the Tesla supercharger network was as expansive as it is now. So you'll see to charge from 51% up to my set point of 90%, it's going to take about 5 hours and 35 minutes, which isn't too long. That's perfect for overnight charging. If I was at a campsite, had a NEMA, or this is actually a J-plug, but if I had, you know, a connection like this at a hotel, be able to charge up overnight, no problem. Or I could just come out after dinner, charged up, unplugged, let the next person charge overnight while I go to sleep, wake up in the morning with a, you know, a charged battery and ready to get on the road. Now some other options, you know, this is using just the J adapter, but we'll go over the Tesla mobile connector next. One note with this J adapter, when you pull it out, you have to pull this adapter out by itself. Sometimes this will get stuck in there and the door may even come down on top of it. To get this adapter out, or anything that's stuck in the charge port, all you have to do is, in the trunk area, there's a hole up here. It might be hard for you to see, but there is a little pull tab, a little pull here. You pull on that. That's a mechanical release for the charge port, and you can remove whatever's stuck in here. Okay, next up we have the NEMA 1450 adapter. Notice these are adapters that come from Tesla. There's a chip in here that tells the Tesla mobile connector what amperage this particular connector can support. So this is a NEMA 1450. It supports maximum of 50 amps of power. Just note that the Tesla mobile connector, it has a maximum of 32 amps it can use. So even though this plug can theoretically give you 50 amps, this can only pull 32. And also note, whenever you're pulling power from an outlet, you can only pull 80% of the rating. So a 50 amp plug, 80% of that is 40 amps. So you can only pull 40 amps on any particular charger. Unfortunately, this is limited to 32 amps. When you use the NEMA 515, 80% of 15 is 12 amps. So with a 15 amp plug, you can pull 12 amps out of it continuously, and that's part of the electrical code, helps protect the wiring. So let's go ahead and try out this NEMA 1450. So nicely, this particular plug is oriented so that the charger hangs down. And the NEMA 1450 is connected to these two breakers at 50 amps. We'll be able to use 80% of that, and then this is just artificially, or it's limited to 32 amps. We'll see a green light on the Tesla mobile connector, means it has power. And we'll go ahead and plug in. Blue light changes to green. You hear a clicking sound on the Tesla mobile connector. And inside the car, you see that we're going to have a maximum of 32 amps. We're slowly ramping up the amperage. We're pulling 238 volts. You'll notice the voltage starts to drop the more amperage you pull, and that's okay. If the voltage drops too much, the car may by itself drop the amount of amperage it's pulling to protect the line. Yesterday I was charging on a 120 outlet, pulling a fair amount of amps on it, but I was only getting like 104 volts. So the car artificially dialed down the charging current to help protect the wiring. Now you can lower the charge current yourself. Notice right now it's set to the maximum of 32 amps and we're pulling 32 amps, but if you want to dial it down manually, you can take the amperage down yourself. And that's for situations where you may have iffy connections. Maybe you're connected to a generator and you got to limit the power. That's an option for you. Notice here that it knows that the mobile connector can only provide 32 amps, so it's going to tell you here the maximum you can draw is 32. It's also the maximum here. Also understand this will remember the location that you're at. If you turn the amperage down, the next time you come here it'll automatically start charging at the set point you had previously. And that's handy at home if you have a special situation where you've turned the charge current down. You can do that. Here we're pulling 8 kilowatts, more than the J or the EV charging station was providing, so that's good. And this is about the maximum you're going to get with the Tesla mobile connector, whether you're charging a Model 3, a Model S, or Model X. And this is why they recommend you get the Tesla wall connector for home use, because it can pull much higher amperage from whatever you can feed it at your home. Up to a maximum, I think the Tesla wall connector supports a 100 amp circuit, or it can charge the vehicle at 80 amps. Most new Teslas can't even charge at that high of a rate, but you'll get the best charging experience at home with the Tesla wall connector and not the mobile connector. This is more for when you're traveling. So at 8 kilowatts, I'll be able to go from roughly 50% to 90% in about 4 hours, 15 minutes, 4.5 hours. Now, if you don't have 240 volt connections, there are other options available, and I'll go over some adapters I have here before I go over that. So here I have a bag of some 240 volt adapters that I had purchased. One I wanted to show you was the NEMA, I believe this is the NEMA 1430. This is the type of plug you found in 1996 and before that with dryers. This is a dryer plug you find in older homes. Those plugs provide 240 volts at 30 amps. So you can use this to convert to a NEMA 1450 and then use your plug here into this adapter and then plug that in the wall. Remember, the Tesla mobile connector thinks it thinks it's connected to a 50 amp circuit. It's going to try to draw 32 amps. But this is a 30 amp circuit. You can only take 80% of 30 amps, which is 24 amps. And they also put a nice reminder on here that max continuous current is 24 amps. So only take 80% of the amperage from the wall. And you're going to have to manually set that in the car yourself, because the Tesla mobile connector will draw 32 amps because it thinks it's connected to 50 amps. So remember, with any of these kind of adapters you use that are not from Tesla, you have to manually dial down the amperage. There's some other adapters here that I haven't used yet, but I have available. This is, I think, a NEMA 1050. This is a 240 volt 50 amp socket, usually for welders. And you can plug into that and give yourself a NEMA 1450 outlet to use to charge your vehicle. This is another one that has 4 different prongs that locks into a generator, and then you can get a NEMA 1450 connection to charge your vehicle just in an emergency. And there's lots of other kind of adapters you can buy on Amazon and other places to convert pretty much any kind of electricity to a NEMA 1450 so you can plug your vehicle in. Tesla also sells other kinds of adapters for various 240 volt connections, but one I want to go over that I think is important that everybody should have in their car, and I wish Tesla provided this. This is the NEMA 520 adapter. Notice it's very much like a standard plug, except one of the vertical plugs is horizontal. And if you look on the plug over here, you'll see that one side has a place for a vertical bar and a horizontal bar. Most household outlets just have the 2 vertical bars. This horizontal bar means that this is a 20 amp circuit, a higher amperage than your standard 15 amp circuit. So with this particular plug, you'll be able to pull 80% of 20 amps or 16 amps instead of 12 amps, which means you can charge faster. So I'm going to go ahead and unplug from the vehicle. Unplug the connector here. And these are a little bit hard to get off. Unfortunately, the ground plug is up on this, which means that the Tesla mobile connector is going to have to hang kind of funny. But this particular plug supports this. We're getting a green light. Now the Tesla mobile connector knows that this is a 20 amp circuit. It'll pull 16 amps into the car. And you'll see here on the screen, maximum 16 amps. We're pulling 120 volts. This will slowly ramp up. And it should take us 17 hours and 10 minutes to basically roughly add 40% more to the battery, which is not great, but it's better than charging at 12 amps, and I'll show you that to you in a second. Just remember, it's going to take 17 hours to get 40%. Let's unplug here. Let's take out the NEMA 520. These connectors are very hard to get in and out. So the NEMA 515 also plugs into this socket. We'll plug it into the car. And at 12 amps, we're still pulling the same voltage. This is a 15 amp circuit, but we can only pull 12 because we're using the NEMA 515 plug. It's going to take almost a day to charge the car. So with that NEMA 520 plug, if you have that kind of plug available, you can get a little bit faster charging when you're out and about. So it's an adapter I think everybody that is on the road should have available to use when you're at a hotel and you're just trying to keep the battery charged up, maybe to preheat it in the morning because it's freezing outside with snow. It's always a good idea to keep your car plugged in, so having all these different kinds of options available for plugging in is a good thing to carry with you. Anyways, I'm going to be going over lots of different things about the Tesla Model 3. This is my first video. If you have any questions, place them in the comments below and I'll catch you later.